Hello students, this is MD Rizwan, faculty for Geography Optional and General Studies. So today we are going to discuss a very basic and fundamental topic of geomorphology that is related to the evolution of the landforms. So when we start with the geomorphology as a chapter, as this is a fundamental chapter you are reading, whether you are preparing for GS or optional, and this is the first chapter of physical geography. So what is a geomorphology? Geomorphology is simply a study of landforms. And what is a landform? How we define a landform? Landform is defined as any structural feature which is made up of rock and it is natural in origin. Three things are there. Any structural feature which is present on the surface of the earth, which is composed of rock and it is created by some natural phenomenon, natural in origin, can be treated as landform. So for example, you say that this is one mountain. So this mountain can be treated as a landform. This is one plateau. This plateau can be treated as a landform. So I'm going with very basic thing. So whatever may be, any landform has two identities. The identity of the landform will be by its height. So how much it is raised or how much is the variation from the sea level, that will be considered as a relief of the landform. And what is the inclination of the landform with the sea level, this will be known as slope. So here we are having two fundamental identities of any landform. One is relief. So suppose I say this is one mountain. So you'll simply measure how much is the height of this mountain. This will be referred as relief. Then we'll see relief is further divided into two categories. One is absolute relief of the landform and second is relative relief of the landform. What is absolute? Suppose you are talking about Mount Everest. So Mount Everest has height of 8,800 meters. So what is this 8,848 meter height of Mount Everest? This is measured from the sea level. This will be referred as absolute. Anything that is measured from the sea level will be known as absolute relief. I am talking about a continental landform. For oceanic, the criteria will be different. Now, if this is a mountain and height is 8,848, this is from sea level. If I say there is adjoining mountain here and there is a valley, now if you are measuring a height of the landform from the nearby lowest level, here we are not concerned about whether the base level is a sea level or not. If you measure the variation of height between any two locations, irrespective of the sea level, that will be referred as relative relief. I hope you are able to understand this. So every landform will have its two type of relief. One, its maximum height from the sea level, known as absolute, and the height measured from the nearby lowest location, irrespective of what is the sea level, or simply the height between the two locations in interior of any landform. This will be known as a relative relief. So landform has two identities, one relief and second, what is the inclination? So I'll write it here, theta. What is the inclination of the landform from the base level? This will be referred as slope of the landform. And yes, these two are interrelated with each other. Suppose I say that this is one landform and this is a hill and it has its inclination. So this is the inclination theta. If the height of this landform is decreasing, obviously the angle of inclination also will get modified. Therefore, relief is affecting theta and theta will affect the relief. So these two are interrelated with each other. So this is the fundamental aspect of landform. Now, what is the complexity? We are saying that landforms are complex. Complexity of landform means the evolution of any landform is complex, and second is that no two landforms are identical. Suppose you say that two landforms are present in the same region, but they are still not identical. Take example Vindhyas, Satpuras. These can be treated as landform, not identical. You can take the landforms like Eastern Ghat or Western Ghat. They are present in the same peninsular region, but they are not identical. Or you take it is Rockies and Appalachians of North America. They are present in the same region, but they are not identical. Therefore, we say that the evolution of the landform is highly complex. And what causes this complexity? We get one basic and simple principle that defines the complexity of any landform. That is, landform is a function of endo and exogenic forces. So, suppose you consider this is the surface of the earth. Now, what is operating from interior of the earth? This is known as endogenic force, and what is operating from outside? This is referred as exogenic forces. So, the crust is the outer layer, and what is this crust experiencing? The crust is experiencing two forces, one from external conditions of the earth, that is exo, and one from interior. What is endo is doing? Endo will create some structure, and what is exo doing? Exo is reducing this. So what is the net result? So if I say that endo and exo are balancing each other, how will be the surface of the earth? The surface of the earth appears to be uniform, it appears to be flat. Lekin it is not happening in this way, right? The intensity and rate of endo is not same at all the places. Similarly, the intensity of exo and exo is not same at all the places. Thus, we'll say that there exists an imbalance between endo and exo. And what is the result of this? This is going to result in development of landform. That is why we are writing the fundamental principle of geomorphology is that the landform is a function of competition. Landform is a function of imbalance, or it is the function of interplay of endo and exo. What we see as a mountain, if somebody is visualizing mountain, experience it as, or you can visualize it as that there might be some endo and some exo operating. What we are seeing today is the product of how these two forces have competed with each other. So, for example, you see Aravali. Aravalis are low-lying structure at many places. Why they are appearing as low? Because here we find that there has been a dominance of exogenic force. If you say Himalayas are appearing to be a huge mountain system. Again, we are saying that here it is a dominance of endogenic forces. Which force is dominating on that region, on that landform, will define the structure or will create the identity of landform. So, what I am trying to tell you here is when you analyze any structural feature on the surface of the earth, you have to check what type of endo and what type of exo has operated on it. You will get the answer for what is the relief of the landform. So, this is one basic principle for complexity. Now, what is exo? So, to begin with, exo is a geomorphic process, means whatever is operating on the landform and trying to degrade. Means what? If there is, suppose this is a mountain and there is an exogenic force operating, what is happening to the height of this mountain? The height of the mountain will be decreased. This is known as degradation, or this will be simply referred as downwesting. Downwesting means reduction in height of the landform, and the same process is known as denudation. So denudation is simply a technical word for degradation. And how is landform coming down? How is the height of the landform declining? We can see that there are two processes involved. Number one is the process of weathering, and second is process of erosion. So I can write here. So basic is, what is denudation or what is geomorphic cycle? One and the same. Denudation or geomorphic cycle is a combined process of weathering and erosion. So to begin with, what is weathering? Weathering is a disintegration of the rock. When the rock breaks, it is known as weathering. And what is erosion? Erosion is a transportation of material or sediment or debris from one location to other. So please try to understand this. When I use a word denudation cycle, geomorphic cycle, all these have the same meaning. That is, the landform is undergoing decline in relief or getting degraded. And how the landform get degraded? Two ways, two processes are there. One, first the rock break, that is known as weathering, and second, the broken material. So in a simple language we can say the disintegrated parts of the rock, the sediment of the rock, the material of the rock is transported by some medium from one location to other. Now what is this medium that transports? That is known as agent of erosion. They say water flowing on the surface might transport, wind can transport, glaciers can transport. So these are some of the important agents of erosion. And what every agent of erosion will do? It will make that area to get modified according to its own intensity. That is why, how is surface modified? How is the earth's surface modified? It depends on what type of agent of erosion has operated. They say where river is flowing, you get a different set of landform. Where wind is flowing, you are getting a different conditions of landform. Where glaciers operate, you get a different conditions of landform. That is why we say that the landscape on the surface of the earth depends on the process of denudation, that is weathering and erosion. So this is a basic introduction of what is a meaning of a geomorphic cycle or geomorphic process. I hope it is clear in this that you are getting an idea of what is a landform, what is relief. Relief is of two types, relative and absolute. What is denudation? It is weathering and erosion. Remaining we will discuss in detail about all these processes in class. Thank you.